Hi and welcome friends. In this tutorial I will show you how you can set IAR Embedded Workbench for your STM32 devices. So the first thing you need to do is you have to create a project from projects menu and you have to select a C project main. Okay. So now I'll suggest you to create a folder for your projects because there will be a lot of files and a lot of documents will be there. So make a project in a folder. So I will create a folder. Let us name is projects dash 1, just project. Okay, now I will keep all the files in this project folder. Also create one another folder, that is E1. So the actual project I will create inside this folder. Why I am creating these folders is to make the folder, make the files put in proper orders. You'll see that there will be lot of files, so it will be difficult if you put everything in one folder without differentiating them into multiple parts. So here I will say this project name as project. Save. Okay, so I created a project, but I have to also save the workspace for this project. To do so, you have to go to save as or save all, or from here you can say save workspace as or save workspace, whatever. So let me save it from here. Okay, so again I will give the same name and delete ewp. Save. Now uh, to create a environment IDE, to set up this environment, there will be a lot of files like library files and the system files, CMSIS libraries. So first thing you need to do is to discriminate those files. You have to create multiple folders. Also I have created one text document for my reference. I always use this text document to set up the environment. I'll suggest you also create such type of document because you can't able to remember all the steps always. Suppose if you are set up the project for today, after 1 month or 1 year you will be unable to remember everything. What are the files you need to add, what are the folders you need to create, how to set up the options. So create a such file for yourself. Okay, so first we will add all the files, all the required files in the particular folders. So let me minimize this also, and I will go to project. Okay, so let me create some folders. mm, Folders. Okay, user folder. In this I will keep my main files and everything. Second, standard std library folder or standard peripherals. Then config. Now standard peripherals, I will keep standard peripherals like UART library and GPIO library, clock library. So those files I will keep it here. Manual configuration, I will keep those files which I need to edit. In some part of that file I need to edit something. That files I will keep in manual configuration. So any other folders? Let me see. Okay, environment create CMS configure standard user. Okay, so that's it I think. Yeah. Now let us add files in these folders. Okay, so before adding the files, you need to download the files. That is library files and everything else. So to do so, you have to go to STM website, or you can just type like for this project I'm using STM32F107 VC, which is a connectivity line of STM32 microcontrollers. What I will write STM32F10 standard peripheral library. Okay. So the first link is STSW standard peripheral libraries. I will go to this link. Okay. So here we can download the files, I think. No, actually this is for STM32054. STM3210 peripheral libraries. Or you can see this link also. So here you will find all the peripheral libraries of multiple boards like STM32F01, F10, F0 libraries, F0, F2. So let us download. So here you can see 32023, 32054. So this one is the newer version, I think. I'll go for this. STM32F0 libraries. Okay, from here, in the end you will find the software. That software. Yeah. Okay, one thing. Here, here I am getting a direct download link. But if you first time you visit this site, you will not get direct link. You will have to fill a form. For example, if I show. Okay. Get software. So as you can see, you have to submit a form, a small form, where you can write your name and your mail ID. The download link will be sent to your mail ID. So from there you can download. So yeah, let me download this. Actually, I have already downloaded this file. So let me not download this and minimize this. Where my download files are in documents, IAR Embedded Workbench. Yeah, libraries. So this is my peripheral libraries. This is the file I downloaded and I extracted it this here. You can see. So let me go inside this file. Now in this file you will find everything you need to set up your project. I'll keep it here. Next thing, I will open my project folder also. This. So the first thing I need to add is assembler file. That is at CMSIS folder. There, yeah. I will go to CMSIS libraries, CMSIS, CMT, device support, STM32. Here templates is the templates IAR. Okay, so assembly file I think I will find in core support devices. Yeah, assembler file is where startup. Yeah, no, IAR. So here I will get my assembler file. Now assembler file is a CMSIS library which I have not added. So I will add another folder, CMSIS. Now which assembler file? Nice question. So okay, so there are multiple assembler files. The first one is startup STM32F10X CL. Now CL stands for connectivity line. Similarly, ST stands for that high density devices. Like if you have STM107 with too many pins, like 100 pin, 120 pins, that comes into high density. Okay, sorry. I think it is for high density stands for flash size. Okay, so my device is connectivity line. First file is added. Now I have to add system file, which is at templates. Yeah. Okay, system file is system STM. So I will add these two files. Includes okay, core file. Core file I will find core support. Yeah. Now one thing for this series F107, the IAR is actually a newer version, and this library is for older version of IAR. So what I have to do is I have to put it at .old. If you have a newer version of IAR, you have to do this. Yes, I have to change it. Okay. Now I have to add standard peripheral libraries. Now standard peripheral libraries you will find at standard peripheral. Now here all the libraries are there. One thing you can do is you can include all the files and put it in standard folder and include all the files, and whatever function is required the IAR Embedded Workbench will choose from accordingly from that file. But what I prefer is to make my code cleaner. I will add only the files which I need. Like miscellaneous is the main files which contain all the configurations and clock cycles and everything is in miscellaneous file. So you have to always add miscellaneous file. Second thing I need is GPIO. Third I need is RCC. Now RCC is also important because it controls all the clock. There are multiple clocks. I will show you in next tutorials. You have to include these files. Then SRC, same. .c of those files. GPIO, RCC. Okay. Now GPIO I am adding because all the products mostly need GPIO pins. That's why it always you require GPIO library. Next thing I need to do is standard done. Then I have to include miscellaneous for GPIO, for clock, templates. Okay, configuration manual configuration folder. Now I will add the files which are needed to be configured manually. So first file is add project STM templates. Okay, project I have to go to projects, STM template, and here configuration files, system STM32. The system I think I have already added. Main.h STM32 configuration. The system I have already added, so this file. Also in E1 there should be some file. No. Okay. Also I have to include one more file. I don't know where it is. Includes, okay, library, this device STM include. Okay, then again, so you have to add multiple files. It's really boring. Includes library, CMSIS, device support documentation, CM3 device support, STM. Yeah, from here I have to include STM34 in this file. I hope I have not added this file in CMSIS library. Yeah. Now next thing is, also you should not add a single file twice. it will generate a error because it will not able to choose which file from the function choose from. Now I have to add a linker file. Now by default there is a linker available, but that does not work properly sometimes, so we have to add it manually. Linker is actually available in IAR Embedded Workbench. So project templates, you want setting, here you will find the linker. You want, here the linker is flash ICF. Okay, so linker I will add in settings because it is a setting file. Now what next? Okay, so I think we have added all the files which are required for this project. Now same files we have to add in EWOM also, because we have to tell EWOM that these are the files, please edit. Before that, let us do some settings. Okay, so select EWOM folder, click next, save as. Yeah, we already did that. Okay, in general option, select target. Okay, now options. So in project you have to click in project here, click options. The first thing is to do is to choose your device. Now as I am telling this for STM32F107 VC, but you can choose any device, and similarly you can download any libraries for those devices. So my device is 107 VC. Okay, next thing I have to do is here library you have to choose full, use SimSim, not okay. Then compiler allows C++, inline semantics, optimization no, output no, list. Okay, so here we have to add all the directories in which all files exist. For example, previously we have added some files into multiple directories like there, but this program IAR does not know where are those files, so we have to tell IAR that here you have to search for the files. So first I will add the project folder. This is our project folder. Okay, now for project folder, actually what happens, it takes absolute values, absolute address. This is called absolute address. Absolute address, like it will go to C drive, user, my username, then desktop, program, project, and EWOM. Now if I change the folder location, it will not able to find those files. So what I will do, I'll tell him that go to project dir. Now it will search for project library, that is this folder. It is now in this folder, project. Now I have to add other folders also. So what I will do, I will add all the folders. This folder I added, debug folder, then settings folder, then project folder, then CMSIS folder. I told you it is a hectic process. I'm already added manual configuration. Then standard peripherals. Also user, I'm not adding any files right now, but later in other projects, when you make a big project, you have to create multiple files. So those files you have to add here. So okay. Now as you see that all the folders are added, but the address is absolute. That is, it will look for C drive, user, then this folder. Now how we can do it such that it will be relative, like one folder above it, then debug. So what you have to do is you have to change it like this, copy this, and paste it here. Then yeah, also you have to change this what we call slash, because for standard this is like this, but when you compile it, it will show error. So change this. Okay, now this folder is one folder behind the main directory, your project directory, that is eworm directory. This is your main directory. Now what to do to go back? Right now what we did, this is our project directory. Go front, you set slash, go into debug folder, slash, go into second settings folder. But what to do to go back? So to go back, you have to do, you have to paste it like this, and there dot dot slash. So dot dot is to go back, like we do cd dot dot in DOS prompt. Now in project folder, we will copy this. Now all the folders are linked to one previous folder. So yeah, paste this. Configuration, paste this. Paste this. Okay, so one folder I have added extra because when I usually count it comes 7, but it doesn't matter actually. Also you have to add some predefined functions here, predefined what we call that hash defined thing. So to do so, I have to go to E1, okay, desktop, project. For that you have to go to configure file, not configure, you have to go to .h file. Yeah, here you will find your predefined function or predefined directory. So I will add it here. Also you have to add one more thing. So where is that folder? Yeah, from this file, I guess. You have to add the your device name. Actually this library is designed not only for one device like 107 connectivity series, but it is designed for multiple devices like all the series of 10. So you have to tell particularly which device you are going to use or which series you are going to use. So I'm using a connectivity line, as you can see. So I have to uncomment it here. Yeah, you cannot uncomment it directly, you have to change the permission for this file. Properties, read only, you have to remove this. Now you can use this file. Okay, save, and also copy this and paste it here. I hope so I'm right. Let me check. Yeah, something like this. 401. So this I already actually written for STM401 RE, but now we are using another controller, so there will be a little minor changes. Like I told you about old, that error took me for 2 days. Okay, now this process completed, I think. Output file. Now what we have to do is, yeah, CMSIS library full C99 inline additional files. This I have added. Output converter. Okay, output. What output you need? Actually normally when you do programming for projects, it's like have a lot of production volume. you have to create some file which you can directly dump into the microcontroller. So you need a binary file to directly convert it, to directly program your microcontrollers without like opening IAR every time whenever you need. You can use this file and STM link software to directly upload your code. It will be like 2 or 3 second process once your code is completed. It's generally used for mass production. Is you use it in our offices. Now what linker? Okay, yeah, linker. You remember we have added one linker file. We have to override this. Now see, here also they are using uh, relative address. Like toolkit directory, then go to this address. They are not adding C drive, then program files, then this, because maybe some user can save it and D drive. So they have added like relative address. We also do it like this. So let me go to the desktop, projects, Q1, setting. I see. Yeah. Now what I will do, I'll remove this Q1 and edit it. Project. Yeah, yeah. Now it is not complete. This one is PROJ, not project. This mistake I always do. Also, this you have to change. Then comes anything else in this settings, configuration. Now configuration is done. What else we have to do? Override default and select project directory settings ICF. Debugger setup driver ST-Link. Yeah. Now debugger. Now what you are using, if you are not using actual your actual STM board and you want to just test your code in whether it is working or not, you can choose it as simulator, but also you can choose it STM link. So what it will do, it will directly upload your code to the your device. Okay, so then you have to say verify download, use flash loader. Then in this you have to choose ST-Link. Here you have to select SWD, and reset mode you have to select normal. Sometime if you are unable to upload the code, try with connect during reset. Sometime it happens that your code is not uploaded properly. So that's it, I think, for this settings. Yeah. Now okay. Next thing we have to do is we have to edit the files which we have kept in manual configuration. So first I will open this file, show you how to edit this. So this file already we have edited, as you can see here. This is the only thing you have to do. It depends on you what line of your microcontroller is, because if you go to STM website you will see there are multiple lines of product available. Like if I go to STM32F1 F1 series, you can see there are many productive lines, value line, then this is STM101 364C. So these are production lines, and if you choose any product you will get to know what production line it is. Okay, so let me close this. Now this file we have edited. Save it. Yeah, already saved. Then configuration file you have to add this headers. We say your peripheral libraries. By default all the peripherals are added, as you can see here. So what I will do, I will remove the comment these all things, because we don't need all the libraries for our project, and we will add those files only which are required by us. So the files which are required by us are GPIO, then RCC. RCC is very interesting file, guys. In later tutorials I will tell you how. Okay, now save. Anything else in settings? No. So save it and close it. Close it. Now we have to create workspace folders like we did it previously. Add for group. Yeah, group. So first one is CMSIS. Also in project folder you have to add all the files. So it's better to categorize. You can add all the files in the directly here, but it's good to categorize things. std lib. Okay, now I'll add one more folder, user. Anything else I have to add? I don't think so. Yeah, now I will add all the files, all the C and S files to the respective groups. Like CMSIS we have got S, C, C. Then standard peripherals, add all the peripheral libraries. C, C, C. Then user, I will put main file inside the user. So that's it. I think we have done. Now we have to include one thing here, our panel library. So include, what is the name of our main library? STM32F1.h. So once you have added this library, all the files will be included automatically, all your header files, because you already added those files into this header file. Actually in this file. Okay, so here you have added all the required files, and this file might have been called from the here. Okay, so I will leave you here now. Let me save this. So till now we have done what? We have included CMSIS multiple files into their folders. Then we have done some settings options. Then we have created workspace folder. Now this is the error which I was getting in that installation. So I've written it here, but it was resolved. So I think the program should run now. I don't remember if I have to do anything else. Yeah. So now you can see the program is showing 0 error, but there are 71 warnings. So what are these warnings? Okay, so actually I put these warnings for you to know that there are some settings are there which are actually does not work when you go from 4 to 1, because as you can see I used reference as STM401 RE, which is the STM Nucleo board for this, like STM32F1. This is a Nucleo board which I use to prepare this configuration files. So I found two errors. First one is the old one, that is the old file was not supported by this file I am talking about. This I have to put old. Now let me remove this old. Let us see what warning I will get. Yes. Okay, then again I have save project rebuild. Okay, so I got too many warnings now. So these kind of warnings you will get. What you have to do is copy this warning and put into Google. Okay, copy Google Baba Jai Ho. IAR compare. See, many people will get same errors. I will go here. This is how I solve the problems. I just put the error code into here and I will find that it is. Is there any solution? No, no solution. If you go search somewhere, you will find surely the solution for this. So here, as you can see, SIMSIS H. So there we are done. Okay, they published all the code. Okay, problem with. Okay, I will remove some of this. Yeah. Okay, so now you can see here is the solution. I rename the outdated SIMSIS file from library. This, for example, be the options library configuration. Use SIMSIM. So I just tried to rename it, and it worked. Oh, yes, Baba, yes. Project rebuild all. Now this warning I am getting here. Okay, so again same thing I will do. I will copy this, paste into Google, and Google Baba will tell me what is the warning. Warning 25. See. So warning I'm getting, what I have to do. IAR assembly is issuing with the warning declaring assembler and blah 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 blah. What I have to do is, in this most of the case, you should add a no root flag to remove the inconsistency and avoid the warning. Okay, you can read this complete problem. I'm not reading this for you. Okay, so which file I am facing this problem? Assembler file. Okay, let me go to the assembler file. I think this one is the assembler. Always use very good note. Yeah. So here I am getting warnings. How to resolve it? Section reorder 1. POBK reorder no root. Okay, I have to add this line. Okay. Where is this? POBK NMI handler reorder 1. So I have to put reorder. Now this is also a read-only file, so I will clear read-only tag. In properties you can go and for this file properties you can go and put it. Okay, like this. Now we have same. Now we have, previously we were getting 71 warnings. Now let me see if it's reduced. Rebuild all. Warning okay, now warning is also there. Wow. And still 71. Okay, what is the warning now? Section code. Okay, here it is 2 times. I have added 2 times. These are the small errors which you will get. Okay, 70 warning. So what we have to do is, we have to do this no root thing all the way, everywhere. Here, here. So I already created a file for, I changed these things in previously, so I will add that file directly. Documents, projects, codes, art, SIMSIM. Okay, assembler file. cl.s. Also you can see I have added this also, but this doesn't use here. You can add all the files here, doesn't matter. Okay, what I will do is I will go to desktop, project, one, extension, replace, replace. So I guess I will not get any error warning. Yeah. So this is how you can create this, set up this IAR Embedded Workbench for your projects. Also, if you want to use Keel or any other development environment, the process is almost same. Just the menu options, and there will be a minor differences. So in next tutorial, I will maybe tell you how to set up environment for Keel or Code EX. Code EX, I think that is the name of that free software. But I will suggest you to use the standard software, because this is the software which is used by professionals. And I'm telling you because in my office I use this software, and whatever developer I talked with in my life, and most of them were using either IAR or either Keel. Okay, so thank you for watching, and have a great day.